Section 8.1 is exploring periodic data. Our goal is to identify cycles and periods of periodic functions and find the amplitude of periodic functions. On page 573, we have a periodic function is a function that repeats a pattern of y values, outputs, at regular intervals. One complete pattern is a cycle. A cycle may begin at any point on the graph of the function. The period of a function is the horizontal length, the distance along the x-axis, of one cycle. The x value in a periodic function often represents time. Periodic behavior is behavior that repeats over intervals of constant length. Example 1 says analyze the periodic function below. Identify the cycle in two different ways. What is the period of the function? So notice we have this zigzag looking graph. We've got this little piece highlighted in red that says one cycle, and then you can see over here highlighted in red again we have one cycle, but it starts at a different spot. The first cycle starts at the top of the peak and continues until we get to the top of the peak again. The second cycle begins on the x-axis going upward and continues until you are again going upwards on the x-axis. Over here we have this blue writing that says period. The period is the length of one full cycle. So again, it is until you start to repeat the same pattern over again. You can begin at any point on the graph and trace one complete cycle. The beginning and ending x values of the cycle determine the period of the function. So on the next slide, we have some examples of answers we could have. So based on the red pieces we have for the cycles, we could say one cycle begins at x equals 2 and ends at x equals 6. 6 minus 2 gives us 4, so the period of the function is 4. So starting from here to here, we can also just count on the graph, 1, 2, 3, 4. That gives us one period. Now I would like you to try problem number 1. Identify one cycle in two different ways, then determine the period of the function.